So it looks like we are simplifying using rational exponents, right? Exponents that can be expressed as fractions. You may not realize this, but like 3 squared, the exponent always was a fraction. It's 2 over 1. We just never show that because this 1 indicates like the first root of 3, which is just 3. So it's just 3 squared 9. But the denominator, you just want to remember this is the Oh, by the way, real quick here, let me explain why I show that to students. So I usually show this to students that this thing always was a denominator of 1, just so when you see a fraction, you recognize the part that is different than normal. In other words, you've always had numerators that were exponents. 3 squared means the square of the 3. And so when you see this 2 up here is still the same 2 here. Like this 2 and this 2 both mean the same thing. Square the darn 8. But when you have a number on the denominator, this is also telling you what root you're taking. In this case, this would be a cube root. And so you get a little bit of a choice here when you see like 8 to the 2/3. You could use the 2 first and square the 8, but that gives you a 64 that you then have to cube root. But that's a little tougher than if you cube root the 8 first and then square it. So you get a little bit of options here. You just want to choose kind of wisely through experience, kind of teaches you that. So anyway, back to solving these problems or simplifying without our calculator. So again, this what this means is, hey, I want a cube root of an 8, and then I want to square that thing. I'm going to square the answer afterwards. So I'm doing that part first. And so if you remember when you're doing cube roots, what this is saying is, what do you have that's multiplied times itself 3 times? And it turns out since 8 is 3 2's multiplied together, when you cube root 3 2's, it's just a 2. Okay, so that's what's going on there. Those we want to memorize though. So certain cube roots you want to memorize. And so find things that are cubed, like 2 cubed is 8. Therefore, the cube root of 8 is 2. These things are just opposites or inverses of each other. 3 cubed is 27. So the cube root of 27 is 3. It just is the reverse of exponents. Okay, so memorize a few of those. You can just look them up or build them yourself. Like you can go 5 cubed. What's that? 5 times 5 times 5. That's 125. Therefore, the cube root of 125 is 5. Remember, this is just asking what's multiplied together 3 times to give you this number? Answer is 5. Okay, so enough about that. Hopefully you understand those. If not, just practice them or memorize a few and you'll get them. So this is cube root of 8, which is just 2. And then we got to square it. So it's just 4. Same thing here. So I do the square root part first. So this is saying square root of 4. And then the 3 is like all exponents. Cube it when you get done. Take it times itself 3 times. So I square root the 4, which is just 2. 4 is 2 times 2. So I can square root it. Then I got to cube it, which is 2 times 2 times 2. Right? And sometimes we get lost, and teachers don't know why students get lost sometimes. And it's because they just don't know quick facts like 2 cubed is 8 or 3 cubed is 27. And if you don't know those, it's really tough to understand that the cube root of 8 just gives you 2. All righty. Let's do this next one. This is a fourth root of the 16. And then the 3 up here says take it times that itself 3 times. And so hopefully, 2 times 2 times 2 times 2. This is 2 to the fourth. And 2 times 2 is 4. So this is like a 4 times. So this is 16. So 2 to the fourth is 16, which means the fourth root of 16 is 2. So the fourth root of 16 is 2. And then I have to cube it. 2 times 2 times 2 is 8. Getting the idea? Ooh, I don't know about 128. Is the seventh root of 128 something I can do? Right? Then after I get done doing it, if I can, I got to cube it. So 128 is a big number, but it's been taken times itself 7 times, whatever the number is. So that's got to be a pretty small one. Let's see. So we just factor it. 2 times 64. Make a little factor tree. 64 is 8 times 8. And see, if we know where 8 comes from, in terms of twos, we know that 8 is a2 times 2 times 2, and this 8 is a2 times 2 times 2. So it looks like 1, 2, 3, 4, 5, 6, 7. So 2 to the 7th is 128. And therefore the seventh root of 128 is just a 2. And so the seventh root of 128 is a 2, and then I have to cube that 2, so I get an 8. 2 times 2 times 2 is 8. Your teacher may also show you this. Like I know now that 7 2's multiplied together is 128. So they may write the 128 as 2 to the 7th, and then those two just cancel each other out, giving you just a 2 to the third power that way. All right, 625. See how it ends in a 5? 625, let's see, 5 times 5 is 25, times 5 is 125, times 5 is 625. All right, so I'm just checking these things. 25 times 5 times 5, 25, that's 125, times 5 is 160 or 625. And so now I know that 5 to the fourth power, 1, 2, 3, 4, of those is 625. And that's important because here I want to fourth root the 625 and then cube it. Well, fourth root of 625 is 5. And then I cube it, and we just did that one actually. That's 125. Okay, he said all of these without your calculators. Oopsie doopsie, missed one over here. Let's do him here. I'm going to deal with the 2 first. So that's a square root of a 4, and then I have to raise it to the negative fifth power. So the square root of 4 is 2. As to the negative fifth. And we can't really evaluate exponents that are negative. It's more of a notation thing saying, hey, I would rather be in the denominator. So it's 1 over 2 to the fifth, which is 2 times 2 times 2 times 2 times 2. These three make an 8. These two make a 4. So 4 times 8 is 32. So 2 to the fifth is 32. So that's 1/32. Which of the following is equivalent to x to the negative 1/2? Let's see here. The 2 means to square root it. So this is the square root of an x, all raised to the negative 1. And that means put me in the denominator. Could be like this. Another way, and I teach my students this as a preference. I say, hey, if you get a negative exponent, put whatever the base is underneath a 1, change the exponent to a positive number. I say, hey, this just indicates it's unhappy where it's at. The x would rather be downstairs. And then this means square root it, and then raise it to the first power is what this little one on top means. But raising something to the first power doesn't change what it is. Notice I put a little 2 there to remind you that's where that 2 is. But usually we don't even show the little 2 when they're square roots. So let's see here. 1 over the square root of x. Looks like it's that guy right there. All right. Numerators are still exponents. Denominators, those are roots, square roots or cube roots or fifth roots, whatever the number is. Let's see here. This is y to the, I think that's a 5 halves. 5 halves. So the 2 means I want to square root you, right? The little 2's right there, but then I have to raise it to the fifth power. So I'm looking for something that does that. Oh, there it is. See, they didn't show the 2. We don't show square roots. That's why this symbol is called the square root, because we're implying there's a 2 there, which means squaring, and we are square rooting. All right, so it's this guy right here. They don't always show that 2. In fact, they never show it when it's a square root. So if there's nothing here, it's a 2. If there's something there, it is what it is. Write without fractional or negative exponents. All right, I like to get rid of the negatives first, so I put the x in the denominator, and now it's a happy exponent. And then the 2 means to square root it, and the 3 means to cube it. And notice they've changed their notation just a little bit here. They've put the 3 on the inside, and you can do that. Remember, we get our choice. We can square root first and then cube. and then cube it, or cube root, then square root. And there they've said, hey, I'll cube the inside, then I'll square root it. And right there, notice like if you were just guessing and you ever got lost, you would have to just recognize that's a square root. And that would almost get you to the answer right away because this is a cube root, so it's not him. This one's a square root and this one's a square root. So at least you'd get it down to 50-50 as long as you know whenever that exponent denominator is 2, it means square root. So you're looking for a radical with no symbol on it because that's implied 2. Alrighty. Uh, Written equivalently as, let's kind of run through this guy. Uh, let's see here. So there's a 2, so I got a square root 4x. And there's a 5, so I got to take it to the 5th power. Now let's see here. I can square root of 4. Well, I'm gonna have to be really, really careful here. He's got every trap kind of set up in your multiple choice here, so I want to do this very, very formally. Um, so let's do it this way. So I go 4x, I might have to square root it, but the answer to that is all to the 5th power. Okay, so if I do my square root first, only the 4 can be square rooted, but the x stays in. But it's still to the 5th power. Now you have a rule for this. When you have multiplication and it's raised to a power, each thing gets raised to that power. And so I've got multiplication here. That's 2 times root x, and it's all to the 5th. So each thing gets raised to the 5th power. And to the 5th, we've seen that one is a 32. And then there's your x to the 5th. Didn't have to do that on any of these other ones so far because inside or the base here was a single thing, and all of a sudden they had a product in here, so we had to be really super careful. Let's see, oh, got ourselves another product. That means you could even separate it if you want to. You could do like everything is raised to the one negative one third now, and then do them individually, right? So negative exponents say, hey, put me downstairs. Now I'm a happy exponent. Put me downstairs. Now I'm a happy exponent. And the threes are cube roots, right? So this is a 1 over, I got a cube root in 8, and then raise it to the 1st power, so that doesn't matter. And I've also got a x down here that I have to cube root, right? And I can cube root an 8, that's a 2, and I can't cube root a single x, so it would look like that when you got done. Oh, there he is, hiding up there in the number 1 spot. Another way to do it, right? Because there's multiple ways to do this, right? Just have to make sure you do one of the methods. So maybe I want to attack it this way. This is 1 over, keep it as a group, raised to the positive 1/3. And now it's 1 over, that means to cube root the 8 and the x. And now I cube root the 8, but I leave the x as whatever the cube root of x is, just like that. Either way, you still get to that answer 1. And finally, equations such as the one below are solved similar to solving incomplete quadratics. Um, Solving the following equation for the value of x is hence the inverse operation to raising a quantity to 3/2 consists of it raising it to the 2/3. All right. So here's what's going on. This equation has one single x right there, and he's going to be pretty easy to get alone. I subtract my 6, gives me what, 54. I can divide by 2, and I can divide by 2 because this exponent is only on the x. It's not on this 2 at all. It'd have to be parentheses around the 2x if that 3f is applied to the 2, but it's not. So I can divide the 2 away, giving me 27. And now here's what all that paragraphing said up there. You can raise this side to the reciprocal of this, 2/3. So you got to do the same thing to that side. So why do we use that reciprocal? It's because reciprocals, 3/2 and 2/3, this is any reciprocals, not just 3/2 and 2/3. It would work with like 8/7 times its reciprocal, 7/8. When you multiply reciprocals, you always get the same numerator and denominators. And so it always comes out to a 1. Doesn't matter what they are, that's an 8 down there. When you multiply, because you multiply fractions straight across, you always get a 1. And so what we do is go, hey, I want to get the x alone. It's got this darn exponent on it. Raise it to the reciprocal because this is a power to a power, and you multiply those. And since they're reciprocals, you just get a 1 up there. And you practically have it solved then because it's just x to the first, which is x. And then you got to figure out what the heck 27 to the 2/3 is. Right? That's where the math comes in. How do I figure out what that is? But again, we just been talking about that. 3 means cube root me. The 2 means square me. So I cube root first because it makes my number smaller. Cube root of 27 is 3. Remember, it's 3 times 3 times 3. And then I have to square it. So I get a 9. 3 times 3 is 9. And I'm done. Right? Not too bad. But this is a nice little cool thing to remember because, like, if you have the square root of x equals 16 and you want to solve that, this is like x to the 1/2. And then I could raise it to the reciprocal, 2 over 1. X equals, because those to multiply to 1, and then I'd have to square that 16 to 56. Because that's a 16 to the 2 over 1. That one means the first root, which is still just 16, so you don't even have to worry about it. All righty. Hopefully that helps you. And that is it.